Yeah, so we'll get into section 1.6 today to start, and again it's on exponent rules. And so the idea here with exponent rules is that there's different ways to combine expressions when you have exponents in them. We've talked about like the distributive property and different ways to simplify algebraic expressions, but now we're going to specifically look at things with exponents. Okay, so quick example, or a couple quick rules for you. The first one is what happens when you take two expressions. We'll say b to the fifth times b to the third. Now I'm going to use the letter b to represent a base. Okay, that's kind of why we use the letter b, but you don't have to. It could use any variable or any number, as long as there's a base there. Okay, so with an exponent, you have a base and a power. And so I've got b to the fifth times b to the third. Now, we know that exponents are really just repeated multiplication. And so that's going to be really the key to all of the rules that I'm going to present today. They all can be broken down as a repeated multiplication and then simplified from there. Okay, so I'm not going to show all the details, but that at least gives you an idea. So b to the fifth is the same as b times b times b times b times b, 5 of them. Okay, so I'm going to write that out. B times b times b times b times b. So that's the first set of 5 b's. Then you have b to the third, which is another set of 3 b's. Okay, so I'm going to multiply to that 3 more. B times b times b. And in the end, I've just got a larger string of b's that are all multiplied together. And so why not just write them as one compact exponent? There's a grand total of 8 b's here, or bases, 8 of the same thing. And so when you multiply 8 of the same thing together, it's like that thing raised to the 8th power. Okay? Now, the relationship between the initial 2 exponents and the final exponent is that you add them together. Okay, so the 5 and the 3 make 8 when you add them. And so this works no matter what size these exponents are. Okay, the initial exponents could be anything, and when you expand it out, the end result is that you're just adding them together. Okay, so in a general sense, or as a general rule, we have something called the product rule for exponents. And the product rule says that b to the x, we go with x there? I'm going to try to be consistent with your textbook. Nope. Your textbook uses b to the m times b to the n. So they use some unknown values for the exponents because it could be anything. It doesn't have to be 5 and 3 there. So b to the m times b to the n is equal to b to the m plus n. You just simply add the powers together. Okay, so this is our product rule for exponents. Now, as we use these rules, I'm just going to write them up on the far right side of the board here, just to keep kind of a running tally of these rules. Hopefully, that won't get too confusing. So b to the m times b to the n equals b to the m plus n. So that's the product becomes a sum. Okay. Okay, so then that's the first rule. Now, all of the other rules really break down in a similar way, so I won't go through all the details of all the rules because that could take the full 2-hour class period or close to it. Instead, I'm just going to tell you that I could do every example or every rule, breaking it down or expanding it out, and then simplifying it and coming up with another general principle like this. So the next one is going to be a quotient rule. So instead of multiplying the 2 bases, you're going to be dividing or putting them in a fraction. So I'd have something like b to the 5th over b to the 2nd. And again, if I expanded these out, just a brief description without writing it all out, it's 5 b's, b times b times b times b times b, over 2 b's, b times b on the bottom. And then you cancel common factors and it reduces down to just 3 b's, so it's b to the 3rd, okay? So you can expand the top, expand the bottom, cancel the common factors, and it reduces down. And so what you end up with in a division problem is a subtraction of the powers, okay? So b to the 5th over b squared is b to the 3rd. The general rule there is called the quotient rule. And I'll just go ahead and write it up here on the side. So it would be b to the m over b to the n equals b to the m minus n. So again, you would be subtracting the exponents when dividing the two expressions, okay? So let's take a look at a quick example that utilizes these rules here, the quotient rule and the product rule. So a quick example might be something like 5 to the 18th power times x to the 24th power over 5 to the 11th, x to the 3rd times x to the 11th, okay? And so in this one, we've got a combination of a couple things. We've got a product down here in the denominator, and we're gonna have some quotients, okay? So the first thing I see are the 5s, right? Anything that matches up. Remember, you have to have the same base to be able to combine things. That's why the b's are the same in the rules, okay? So the bases have to be the same. I cannot combine a base of 5 with a base of x. That won't work. But the 5s go together, the x's go together. So 5 to the 18th. Well, let's not worry about the quotient rule yet. Let's actually start with the product rule. We'll just take care of one thing at a time. So look at the x's on the bottom. They're multiplied. I can add the powers together. That will equal 5 to the 18th times x to the 24th over 5 to the 11th. Again, you're going to add those powers. It'll be x to the 14th. Okay? All right, so that works out pretty well. Then we're going to use the subtraction on the quotient rule to get these to simplify further. So I end up with 18 minus 11, which is 7, so that's 5 to the 7th power, and 24 minus 14, which is 10, so it'd be x to the 10th power, okay? Now, generally speaking, if these powers are large on a number like 5 to the 7th, I won't have you calculate those because the numbers get pretty big and it's just kind of unnecessary to write it out. However, if it's something like 5 squared, you could put 25 in there, or 5 to the 3rd is 125. So some of those would simplify, no problem, but 5 to the 7th, don't worry about it. You can leave some of those bigger ones in that form. When you're on my math lab, it will tell you what form to leave it in. So if it tells you to leave it in exponent form, do that. If it says to expand it or to write it as a single number, then go ahead and do that. Just make sure to follow the detailed directions in my math lab. Okay. Okay. So there are several other exponent rules. These are two of the basic ones, the product rule, the quotient rule. And let's see. The next one deals with exponents that are a little bit different. So instead of having all positive number exponents, we're going to have zeros and negatives in the exponent. Okay, but the rules governing those come from these two. Okay, particularly the quotient rule. So get my eraser. So we have one called the zero exponent rule. And the zero exponent rule, basically the idea there is that if I have something like, well, let's go 8 to the 0 power. Well, 8 to the 0 power could be seen as a subtraction where both terms are the same, right? So it's kind of like, you could think of it as, you know, if I had 8 to the 5th over 8 to the 5th, then when I subtract those powers, I would get 0, right? 5 minus 5 is 0. But anytime you have the same power on top and the same power on the bottom, well, the same thing on top and bottom, they cancel and you just get 1. So the answer ends up being 1, okay? So it kind of comes from this quotient rule. Again, I'm not going through all the details of how that works, but I just chose the number 5 here randomly. You could put any number as long as it's the same on top and bottom to prove that this works. But anyway, a zero exponent will always be 1, okay? So as a general rule then, b to the 0 will equal 1. Now there's an exception to that, as long as if the base itself is 0, if you had 0 to the 0 power, that's undefined. You're not going to see that happen very often, if ever, in this class. But I just want to point that out. Maybe we will in the exponential function chapter later in the book. But for right now, just know that a base raised to the 0 power will always be 1. Okay, so that's a zero exponent rule. Then we also have something called the negative exponent rule. I'm abbreviating a bunch of stuff here, but that's, you know, rather than writing it all out. So negative exponent rule. And again, so what happens if instead of having positives or 0, we have a negative there? Well, negatives come from a subtraction where the second term is bigger than the first. Okay, so that would mean the bottom, the denominator, has a larger exponent or more factors than the top does. And when you cancel, that just means there's things left on the bottom, but not on top. Okay, so you know, you might see this in something like x to the 3rd over x to the 7th. You've got more on the bottom than you do on the top. When you subtract, you end up with a negative power, right? You'd have x to the negative 4th. But if you think about expanding these out and canceling, you have 3 x's on top, 7 on the bottom. When you cancel, you just have 4 on the bottom. So really what you're left with is 1 over x to the 4th. Okay, so in both cases, you have, or you have two different cases, I guess. You have one where you have a negative exponent and one where the positive exponent is on the bottom. And so as a general principle, if you had a base with a negative power, we'll say b to the negative m, well, that's the same as 1 over b to the m. Okay, so a negative power becomes positive on the bottom. Okay. All right, so let me write that up here. B to the minus m equals 1 over b to the m. And what's interesting, and again, I'm not going to go through the detail here either, but what's interesting is that if you end up with a negative power on the bottom, it becomes positive on top. So it basically switches places when you change the sign. Okay, so a similar rule then would say b to the m is equal to 1 over b to the negative m. Okay, so if you have a negative on top, you end up with a positive on the bottom. If you have a positive on top, it's the same as a negative on the bottom. So you can switch the position of the factor based upon the sign of the exponent. Okay, so that's the negative exponent rule. Then we have 1, 2, 3 more. We have 3 more. So we've got power to a power. So yeah, 3 more rules left, and then we'll just do a few problems, show you how to work through those, and sort of combine them all together, and I'll take some questions after that. So okay, so power to a power. So if I had something like 5 to the 3rd raised to the 6th, okay, again, here's a power raised to a power. I can again think about expanding these out. So in the parentheses, I have 3 5s. I have 5 times 5 times 5. And then when I raise that to the 6th power, I have 6 copies of those 3 5s. So I'd have 5 times 5 times 5, and 5 times 5 times 5, and 5 times 5 times 5, that's 6 times, right? I'm not going to speak it all, it's confusing. But 6 copies of 3 5s. If you have 6 copies of 3 things, you really have 18 of those things, right? So 6 times 3 equals the 18. So in the end, you're multiplying the 2 powers together to get the final simplified result. And again, rather than write out all that expansion, I'm just going to give you the final result. So as a general rule, power to a power, you multiply the 2 powers together. So if I had any base raised to a power, and then that raised to another power, it would be simply the base raised to the product of the 2 powers. So it would be b to the m times n, or mn power. Okay, so I'm running through all these rules. We'll take questions in a few minutes. Let's see. So that's power to a power, and then we're going to have one called a product to a power. And in the product to a power, instead of having a power on the inside of the parentheses, we're going to have a product of 2 things, kind of like this one. But then raised to a power. So something like a times b raised to the 3rd power, for instance. Well, a times b to the 3rd is 3 copies of a and b. It's ab times ab, which is really 3 a's and 3 b's, and so you end up with a cubed and b cubed. Okay, so essentially this power applies to both factors in the parentheses. And so you have a cubed times b cubed, okay? So as a general rule, the product to a power rule is a times b raised to the m power is the same as a to the m times b to the m, okay? So it kind of works in a similar way to the distributive property for multiplication. So essentially this power, in a sense, distributes or applies to each of the factors in the parentheses. Don't confuse this with distributive property in the sense that the sign in here has to be, or the operation is different, right? Distributive property, you have a plus or a minus. With the exponent rule, you have a multiplication, and in the next one we'll have a division. So the product to a power is going to be a times b raised to the m is a to the m times b to the m. Okay. Oh, I spaced that out just right. I've got one more property and space for one more. The next one is called the quotient rule. Or the quotient to a power, sorry, the quotient rule is up here. Quotient to a power rule is the next one. And so instead of having a product in the parentheses, we're going to have a quotient or a fraction. Okay, so we'd have a over b raised to the m power. And of course, you can imagine what would happen, just like with the multiplication, the power applies to both the top and the bottom. And so we end up with a to the m over b to the m, okay? Just a quick example, if I had something like 2/3 raised to the 5th power, Well, 2/3 to the 5th is really 5 copies of 2/3. Okay, so you'd have like 2/3 times 2/3 times 2/3 times 2/3 times 2/3. So 5 copies of 2/3, which is 5 copies of 2 on top, and 5 copies of 3 on the bottom. So it's like 2 to the 5th and 3 to the 5th. Rather than expanding it all out, we can just apply that 5 to both spots. And of course, these we could calculate, but I'm not going to worry about it right now. Okay, so that gives us, I got to write down the final rule there. So A over B to the M is A to the M over B to the M. Okay, so that should give me all of my rules. 1, 2, 3, 4, 5, 6, 7, 8 rules there. Okay, and in some sense, the 2 negative rules are basically 2 different variations of the same thing.